Hello, algebra students. Today we're going to talk about functions, excuse me, graphing functions. And it's going to be on page 42 in your composition book. And we're going to be using pages 42 and 43. So we'll need 2 pages for some stuff we're going to do in a second. But this is section 4.7, graphing linear functions. Now, if you remember from way back at the beginning of the year, we talked about functions, and we talked about the 7 different ways to represent a function. And one of those was through an equation, and another way was through function notation. Well, we're going to use that function notation today as we talk about graphing a function. It's really not any different, it's just written a different way. So any equation, y equals mx plus b, for example, can be written in function notation. And the only thing that's going to change actually is the y. And instead of the y, we're going to put the f of x, or the g of x, or the h of x, or the k of x, or whatever, equals mx plus b, where this x and this x are exactly the same. And this whole function notation f of x still is the same thing as y. So if we're given some instructions that say something to the effect of evaluate this function when x equals -2, 0, or 3, I'll write that. Evaluate the function when x equals -2, 0, and 3. And they give me a function, f of x equals 12x plus 1. I just substitute each one of these values for my x and figure out what the function is. So then the answer would be in function notation, the f of x equals, and then you put it in set notation. 12 times -2 is -24 plus 1 is -23. 12 times 0 is 0 plus 1 is 1. And 12 times 3 is 36 plus 1 is 37. So that would be the value of my function based on x equaling -2, 0, and 3. Now something else they might ask us to do is to find the value of x so that the function has a given value. So instead of actually solving for y, this time I'm going to solve for x. And the problem would look something like this. The f of x equals 6x plus 9, and then they have a 3 after that. Well, what do I do with that 3? That 3 is what y is going to equal. And so I've got to figure out what value of x do I need so that this y equals 3. So I'm just going to plug the 3 in here, equals 6x plus 9. I'm going to move the 9 to the other side, so we have 6x equals -9 plus 3. So -6 equals 6x. Divide both sides by 6, and x equals -1. So in this case, the instruction was a bit different. Find the value of x so that the function has the given value. So take this number and plug it in for the function value, or y. The next thing we want to look at is how we compare functions or the graphs of functions to each other. With linear equations or linear functions, there's a parent function. And that parent function is the f of x equals x. Or we could write it in a different way as y equals x. That is a line that passes through the origin and has a slope of 1. So if we looked on a graph, it would just go right like this. That's our parent function. It goes directly through the origin and has an up 1 slope, up 1 over 1, up 1 over 1, up 1 over 1, all the way through. That's the parent function. And so oftentimes you're going to be asked to compare your graph to the parent function. Well, I told you that m equals 1 and b equals 0. So the way we would compare, and I'm going to look at example number 1 over here on the solution. If you'll notice, this line right here is my parent function. That's the parent. It's y equals x. Now we have another function down here that is a dashed line, And that equation is the p of x equals x minus 4. So you'll notice that the slope is the same because m is still 1, but the y-intercept is different. And when we have the same slope but a different y-intercept, the lines are parallel and their translation. So this dotted line right here is a translation of the parent function. So we call that a translation because the only thing that's changing is the y-intercept. And in this case, it would be a translation down 4 because the y-intercept is at -4. So we take this whole line and we just move it down 4 spaces on the y-axis, and we have a translation down 4. Now, if you look over here at example B, you'll see that example B went from a positive slope in the parent function to a negative slope right here. I'm pointing at that line right there. That's a negative slope. Anytime the slope is negative, we call that a reflection. So once again, it's a reflection when slope is negative. And you'll also notice that the slope here is -2. It still has the y-intercept of the origin. That doesn't really matter at this point, but the slope is -2. Now I look at the absolute value of that slope, and I see that the absolute value of -2 is +2. So anytime my slope is bigger than 1, we also call that a stretch. M is greater than or equal, not equal to, m is greater than 1. So if my slope of my other line is greater than 1, or the absolute value is greater than 1, then it's called a stretch. Now we're going to look at the bottom part of that page that you have that I gave you to tape into your composition book. I just blew it up larger so it's on one page, but yours is in your composition book. So we're going to kind of sum all of this up. We have here, this is my parent function. It passes through the origin and has a slope of 1. This line, we're going to call it line, I don't know what we'll call it. We'll call it line A. Line A has the exact same slope. You can tell the parallel, but it is a translation up. So the graphs have the same slope. The graphs have different y-intercepts. Graphs of this family are translations of the graph f of x equals x. This one was a translation up 2, and this one was a translation down 3. Now, the graphs in this second section, here's the parent function again, and I've got a line here, we'll call this line T, and this line P. Notice that line P looks like it has a slope of 2 based on rise and run. And line T looks like it has a slope of 1/2 based on rise and run. So T, m equals 1/2. Now, the graphs have different slopes, but they have the same y-intercept. Graphs of this family are vertical stretch or shrinks of the graph f of x. When the absolute value, when the absolute value of m is greater than 0, it's a stretch. When the absolute value of m is less than 1, it is a shrink. This number is supposed to be 1. It's when the absolute value of m is greater than 1, it's a stretch. When the absolute value of m is less than 1, it's a shrink. And again, we'll talk about this more in class if this is confusing, but go ahead and write these notes down. And so now we're going to look at this. Here again is our parent function. And you'll notice that both of these lines that are there have negative slopes. The graphs have different slopes, but they all have the same y-intercept. And graphs of this family are vertical reflections or shrinks or stretches. So let's call this, this line is going to be line W. Notice that line W has a slope of -1. So the absolute value of that is still 1, so that makes it just a reflection. Now if we look at slope Z, Z looks like it has a slope of -1, 2, 3, -3. So that makes it a reflection and a stretch because the absolute value of M equals 3, which is greater than 1, so that it is a stretch. And again, I understand this is a lot of material, but I want you to get it written down and maybe look over it a couple times before we come to class on Monday, and we will wrap it all up together. And your assignment for this video is to send me 2 questions that you have about what you just watched, okay? Anything that's confusing or that you don't understand or that you thought, hey, I wonder if this relates to that. Just send me 2 questions as a direct post on Edmodo, and I'll do my best to answer those in class on Monday.